This lesson is on section 3-3, solving multiplication equations. So my first example is, so the last lesson was on adding and subtracting equations. This lesson is on multiplying equations. So for this example, 8 times q, or 8 times some number, equals 56. And a lot of you are thinking right now, oh, I know exactly what this answer is. But I want you guys to get in the habit of showing your work correctly, because especially when you get into 7th grade, you're going to have a lot trickier problems, and especially when we get into our next lesson, we're going to be adding a little bit more difficulty to the equations. So let's show our work correctly. So we're going to first write the equation. 8 times some number equals 56. All right, so now I'm going to think about what's the opposite of multiplication. Well, the opposite of multiplication, because that's what you see in this problem, is division. So what I'm going to do, I'm going to divide 8 to both sides of the equation. Notice I'm just doing my fraction bar, and then I'm dividing 8 to both sides of my equation. I'm putting 8 right under 8 and 8 right under 56. Now I'm going to draw my line just like I did to simplify in the last lesson. So 8 divided by 8 is going to equal 1, and that's our goal, is to just keep q, or keep our variable by itself. So I'm going to bring down q, because 1 times any number is just that number. So we can just write this as q. We don't have to put 1q. So q equals 56 divided by 8 is 7. So now I have to check my work. I'm going to plug 7 back into my equation. So I'm going to say, does 8 times 7 equals 56? And I'm going to say 56 does equal 56. So my answer checks out. So my answer really is q equals 7. My next example is 45 equals 5 times some number, or 45 equals 5x. So what I'm going to say here is, and again, this equation is just flip-flopped around. Don't get confused by this. Just the equal sign is on the other side of this equation. So what I'm going to think about first is I'm going to think to rewrite the example. 45 equals 5 times x. Or again, like I did in the last video, I can erase this and I can say 5x, or 5 times x equal 45. I just flip-flop this around. It doesn't matter. It's commutative. So what we can think about here is, what's the opposite of multiplication? Well, the opposite of multiplication is division. So I'm going to just divide both sides of my equation by the number that's next to my variable, or by 5. Now I'm going to draw my big line. 5 divided by 5, that was my goal, to make it a 1, to get x by itself. So I'm going to bring down my variable x, and I'm going to say 45 divided by 5 equals 9. Now I need to go back and I need to check my work by plugging 9 into my variable. I'm going to say, does 45 equal 5 times 9? And 45 does equal 45. So my answer checks out. So my answer is 9 equals, or x equals 9. And my last example is negative 18 times some number equals 36. So the only difference with this one is I tossed in a negative sign, and it doesn't mean anything different. We just have to think about our negative and positive rules. So I'm going to rewrite the equation. Negative 18 times some number equals 36, or negative 18x equals 36. So the opposite of multiplication that's going on in this problem is division. So I'm going to divide both sides by negative 18, or divide it by the number that's right next to my variable. Negative 18 divided by 18, it's going to cross off and make my 1. So that was my goal, to get x by itself. And 36 divided by negative 18, well, a positive divided by negative is a negative. And 36 divided by 18 is 2. So my answer should be x equals negative 2, but I always have to go back and check. I'm going to plug in negative 2 back into my equation. So I'm going to say, does negative 18 times negative 2, does that equal 36? Well, a negative times a negative equals a positive, and 18 times 2 is 36. So 36 does equal 36. So my answer checks out, and my final answer is x equals negative 2. And that brings me to the end of the lesson on solving multiplication equations.